Hi kids, and welcome back to Stoichiometry. Now, what that stands for is how much stuff can I make with a certain amount of other stuff. And when we look at a chemical reaction, here's how we should read it. We should say, for every 1 unit of N2, I react that with 3 units of H2 and form 2 units of NH3. Now, the units we use in chemistry are called moles. Alright? Not the fuzzy little animal like over there, but moles. The amount of a substance required to weigh its average atomic mass in grams. Anyway, taking a step back, let's look at a couple problems right here. How many moles of NH3 can be made from 5 moles of N2? Well, we have a starting point, and we're going to use the factor label method like we have all year, and that's not going anywhere, folks. 5 moles of N2. Now, what we're going to do is we're going to use the molar relationship of these presented in this equation. So, for every 1 mole of N2 that I use, I can make 2 moles of ammonia. So, I would write this ratio out. I'm looking to form ammonia, so I'm going to put that on top. The unit that I already have is nitrogen, so I put that on the bottom. And the ratio that we have here from our chemical reaction is, for every 1 N2, we can get 2 NH3s. So when you multiply this out, this tells us that we can make 10 moles of NH3, or ammonia. Okay. So what good does that do us? Can you weigh out a mole? Do you have a balance that can tell you that? I don't think so, because you don't. So what we measure things in the chemistry lab is we use grams. We use electronic balances to figure out how much stuff is going to weigh. Now, the nice thing about moles is we can use our periodic table and the number of moles to figure out the mass of things. So, say you made 10 moles of ammonia and you wanted to know, how much will this weigh? First thing we need to do is find out how much each mole of ammonia weighs. So, if our substance is NH3, that means we have 1 atom of nitrogen and 3 atoms of hydrogen in every molecule. So, when we look on the periodic table, nitrogen has a molar mass of 14 grams per mole. We only have 1 of them in this compound, or molecule rather. So that totals 14 grams per mole for nitrogen. Hydrogen only has 1 gram per mole, but we have 3 of them. So in finding the total molar mass of this compound, we find it to be 17 grams, and that's what 1 mole of NH3 weighs. So, if I have 10 moles coming from there, 10 moles of NH3, and we use our relationship here, just like we have all year with our factor label method. For every 1 mole of NH3, we have 17 grams of NH3. So, the moles will cancel out. It'll be left in grams, and our answer would be 170 grams of NH3. So we could make that much ammonia from 5 moles of nitrogen. Thank you.